coherent and incoherent addition of
waves. The entire field of interference is based on the superposition principle, according to which, at a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacements produced by each of the waves. Consider two needles, S1 and S2, moving periodically up and down in an identical fashion in a trough of water. They produce two water waves, and at a particular point, the phase difference between the displacements produced by each of the waves does not change with time. When this happens, the two sources are said to be coherent. Shows the position of crests, solid circles, and troughs, dashed circles, at a given instant of time. Consider a point P for which S1P equals to S2P. Since the distances S1P and S2P are equal, waves from S1 and S2 will take the same time to travel to the point P, and waves that emanate from S1 and S2 in phase will also arrive at the point P in phase. Thus, if the displacement produced by the source S1 at the point P is given by y1 equals to a cos omega t, then the displacement produced by the source S2 at the point P will also be given by y2 equals to a cos omega t. Thus, the resultant of displacement at P would be given by y equals to y1 plus y2 equals to 2, a cos omega t. Since the intensity is proportional to the square of the amplitude, the resultant intensity will be given by I equals to 4 I0, where I0 represents the intensity produced by each one of the individual sources. I0 is proportional to A2. In fact, at any point on the perpendicular bisector of S1, S2, the intensity will be 4I0. The two sources are said to interfere constructively, and we have what is referred to as constructive interference. We next consider a point Q for which S2Q minus S1Q equals to 2 lambda. The waves emanating from S1 will arrive exactly 2 cycles earlier than the waves from S2 and will again be in phase. Thus, if the displacement produced by S1 is given by y1 equals to a cos omega t, then the displacement produced by S2 will be given by y2 equals to a cos omega t minus 4 pi equals to a cos omega t, where we have used the fact that a path difference of 2 lambda corresponds to a phase difference of 4 pi. The two displacements are once again in phase, and the intensity will again be 4I, not giving rise to constructive interference. In the above analysis, we have assumed that the distances S1Q and S2Q are much greater than d, which represents the distance between S1 and S2, so that although S1Q and S2Q are not equal, the amplitudes of the displacement produced by each wave are very nearly the same.